For question number 1, let me just zoom out a little bit. For question number 1, the correct answer is answer choice number 1. We'll go through that one and then we'll talk about why the other ones are incorrect. So a counterclockwise rotation of 90 degrees, and I'm not going to do this exactly because I don't want to take too much time. I'm just going to put like approximately where it would be. I'm going to like freehand it. So if I turn this 90 degrees counterclockwise, we're going to have A over here, B over here, C over here. And then A matches up with D like it's supposed to. B matches up with E like it's supposed to. And F matches up with C like it's supposed to. So that's good. So answer choice 1 is the correct answer. Let's talk about the other ones. In answer choice 2, so a counterclockwise of 90 degree rotation of 90 degrees. So that's what we had before, followed by a reflection. So if we flip it over, it's no longer going to be facing the right way. It's facing the right way after the 90-degree rotation. If we flip it over, it's not going to be facing the right way. So that's why answer choice 2 is incorrect. Answer choice 3, after the 90-degree counterclockwise rotation, says a translation 4 units down. It's not moving down, it's moving to the right. So goodbye to that one. And number 4 is a clockwise rotation of 90 degrees. So we're going this way instead. And just to show you the orientation, it's going to look like that. So A is going to go down here, C and B. If I turn it 90 degrees, it's going to look something like that. Once again, I just freehanded it. Not exact, but that's going to be the general shape. Followed by a reflection over the x-axis. So then if I flip it down, so if I flip it over, it's going to look something like this, where C is going to flip over down here, B is going to flip over down here, and A is going to flip over down here. But remember, A is supposed to match up with D, and it doesn't. D's here, not over here. B is supposed to match up with E, it doesn't. So it's not facing the right way. So answer choice 4 is not going to make the shape face the right way. Answer choice 1 is the correct answer here. Okay, for number 2, which transformation would not carry the square onto itself? So number 1 says a reflection over the y-axis. That's not a line of symmetry. So that's not going to, if I fold it over, it's not going to look like itself. It's not a line of symmetry. So that is the correct answer choice. Let's talk about the other ones. X-axis is a line of symmetry. A rotation of 180 degrees around the point 1, 0. The point 1, 0 is in the center of the square. So if I rotate that 90 degrees or even 180 degrees like it says here, it's going to still look like itself because I'm rotating it around its center. Reflection over the line y equals x minus 1. So that line, there's an invisible 1 here, so the slope is 1, which means I'm going to go 1 up and 1 over. And the y-intercept is -1. So that's where I'm going to start graphing, at -1. And then I'm going to use my slope, up 1 over 1, up 1 over 1, up 1 over 1, to get more points on this line. And as you can see, it is a line of symmetry. It's one of the diagonal lines of symmetry. So number 1 is the correct answer here. That's the only one that wouldn't make it look like itself. Number 3 is rotational symmetry. Remember to find the minimum number of degrees that something could be rotated to look like itself about its center. We could do 360 degrees divided by the number of sides and angles, which is 10 for the decagon in this question. So that is 36 degrees. 36 degrees is not a choice. So we have to see which one 36 is a multiple of 36. So you can take each one of these and divide by 36 and see which one gives you a whole number, which one goes in evenly. And that will be 252. For the next one, I'm not even going to use the graph. You can use it if you want to. It's here. But our ending point is negative 3, 4. We're looking for our starting point. To get from the starting to the ending point, we did a translation of 2 to the right and 1 down. This is to the right. That's the movement on the x-axis. This is down because it's negative 1. It's the movement on the y-axis. So in order to go backwards, because I'm not going from the beginning to the ending, I'm going from the ending to the beginning, I could just do the reverse. Instead of moving 2 to the right, I can move 2 to the left. Instead of moving 1 down, I can move 1 up. So, oops, let me put that back. Sorry about that. So negative 3 minus 2, that's negative 5. You can use a calculator for that. I know it's weird because you're getting more negative. You're moving further away from 0. And then 4, if I increase it by 1, that's 5. And I can double check by doing the translation here and seeing if it matches up. So if I go 2 to the right, if I add 2, I do get from negative 5 plus 2 is negative 3. And if I go 1 down, if I take 5 and I subtract 1, I do get 4. So the correct answer here is negative 5, 5. Okay. Which one is always true? So a reflection and a rotation are both what we call rigid transformations. And a rigid transformation makes congruent figures. So basically, we're looking for which statement is true. So BC is congruent to EF, BC, EF. Those do correspond. Second and third letter, second and third letter. So that is true. They will be the same because they correspond. So before and after, where did it go? I think I deleted the whole page. Let me try to put it back. There we go. So before and after the rigid transformations, this will be true. A and F. A and F are not in the same spot. That doesn't work. A matches up with D. A does not match up with F. AC matches up with DF, not DE. And B matches up with E, not D. Over here, angle 1 is 7x. Angle 2 is 5x plus 30. If I highlight the lines in the transversal, you could see that letter Z. These are alternate interior angles. They're within the lines on different sides of the transversal. And it's asking when the lines will be parallel. So if the alternate interior angles are congruent, if they're equal to each other, if this is equal to that, that will ensure that the lines are parallel. So subtract 5x, divide by 2, and you can show all the work on your paper. That's 15. And it was just asking for the x value. Okay, over here we have AB congruent to DE. Make sure to mark your diagram. We have AC congruent to DF. And we have angle A congruent to angle D. And we need to write a sequence of transformations that maps triangle ABC onto triangle DEF. So there's multiple ways that you can do this. You could even do this with a reflection, but I am personally not going to do it with a reflection. So either you can do it first with a translation. You can translate along CF, so that C and F are touching, and then you can rotate around point F in a clockwise direction until, for example, until like A matches up with D and AB matches up with DE, until the parts that are supposed to match up. Or you can start with the rotation, followed by the translation. I think I'll do the rotation first. It doesn't matter. So I'm going to do rotate around point C in a clockwise direction until AC is parallel to DF. So until these are parallel. Okay. Translate along BE. And just to make it more complete, I'll say until angle A matches up to angle D, just because that was provided in the question, until AB matches up with DE, because that was provided in the question that those were supposed to match up, and AC matches up with DF. Alternatively, so this is one way. The second way you could have done it, I'm not going to write it down. You could have translated along CF and then rotated around point F until the stuff matches up. Doesn't matter, as long as you fully describe your transformation. For rotation, you do need three things. You need the point you're rotating around, the direction, and when to stop. We don't have an angle here. A lot of people are saying 90 degrees, 120 degrees. We don't have a grid. I don't know exactly what angle measure. What if it's 89 degrees? What if it's 91 degrees? How would I know? I have no way of knowing. We don't have a grid. So we can't be making that up. Okay, let's take a look at this one over here. You cannot just do a translation. It doesn't work because bike, golf. B should match up with G, but B's on the left and G's on the right. I should match up with O. Okay, those are in the right spots. K should match up with L. K's on the right, but L's on the left. So this is not oriented correctly. So translation is just going to slide it. It's not going to fix that orientation. What a lot of people did was either a translation followed by a reflection or a reflection followed by a translation. I'll do the reflection first. So I'm going to reflect over y-axis. And if you reflect over the y-axis, 1, 2, 1, 2, it should fix the orientation. Moving equal distances. Okay. And now notice that it's not in the right spot, so it needs to be moved. E needs to match up with F, so I can just see 1, 2, 3, 4, 5. Translate 5 units up. This was the tricky one. A lot of people got this one wrong. So the original shape has the coordinates. I deleted again. Why do I keep deleting it by accident? 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 1, 2, 3. So first we're going to be reflecting this figure over the line x equals 1. This is not the line x equals 1. This is the line x equals 1. So I'm going to move this equal spaces over the line. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 6, 7. And to get partial credit, and on the Regents exam too, you really should write down your coordinates. Otherwise, you might not receive credit in the future. So definitely make sure that you write down your coordinates. 1, 2, 3, 4, 5, 6, 7, 8, -3. 1, 2, 3, -3. 4, -1. And it'll be helpful for the rotation. 1, 2, 3, 4, 5, 6. And you'll see why in a second. So now we're going to do the rotation, and we are rotating 90 degrees counterclockwise, centered at the origin. So here's our center of rotation. We don't want to confuse. And the way that I like to think about rotating is the same way as we do with the tracing paper, where I'm going to take the center and I'm going to connect it to my point. And if I'm rotating 90 degrees counterclockwise, that's this way. So it's going to end up in this box over here. So notice that L shape I drew, connecting the center to the point. You imagine rotating that L shape 90 degrees counterclockwise will look like this. So we're going to be moving the long way this way and the short way this way. So that's 1, 2, 3, 4, and then 1. So 1, 2, 3, 4. And that's point T prime. And it might get a little bit confusing with all of these connections, so feel free to erase after you find the point. And I found T double prime first. So I'm going to put down the coordinates. 1, 4. And notice why I told you it was a good idea to write down your coordinates is because notice how it's the same numbers. It should be the same numbers. They might be different signs, but it should be the same numbers. Otherwise, you did something wrong. Use blue this time. From the center to my point. 1, 2, 3. 1, 2, 3. 1, 2, 3. 2. There we go. A double prime. 1, 2, 3. 1, 2, 3. And that's the point. 3, 3. Notice the same numbers, different signs, but same numbers. Okay, I'm going to use a different color next. I guess I'll use black next. I haven't used black. So I'm going to connect from the center. Oh, I went too far. Oops. I'm trying to go to point H. There we go. So that's 1, 2, 3, 4, 5, 6, and then 1. 1, 2, 3, 4, 5, 6. H double prime. And that's 1, 1, 2, 3, 4, 5, 6. Notice the same numbers, just, mixed up, different signs, but the same two numbers. And then finally, I'll do this one with yellow. It's going to be a little bit hard to see, sorry. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So that is 3, 8. And notice the same two numbers, just different signs mixed up, but same numbers. And I'll connect it with a different color. Let me use orange so it doesn't get confusing. And here it is, rotated 90 degrees counterclockwise. So that's how I like to do it. But once again, you got half credit if you did the reflection right. Always a good idea to write out your coordinates. And then you can kind of, if you know it's going to end up in this box, you can figure out what the coordinates are, You just got to know what box it's going to end up in, especially if you're centered at the origin. Then it's going to travel around the boxes. Are the pre-image and the image after the sequence congruent to each other? Yes. Reflections and rotations are rigid transformations that preserve side lengths and angle measures. Okay, so this one, it says explain, and a lot of people weren't explaining. On the Regents exam, they don't give you any credit except for what you write in words. Because if it's an explanation credit, you're only getting credit for the things that you put in your explanation. You can put whatever work to support it on your paper to make it more clear to the reader. In fact, if there's work, you should have work. But you only get credit for what's actually written up in words. So I was super, super, super lenient this time. But in the future, if you have a question that says explain and you don't have words or you're missing things from your explanation, that's not going to be credit. So first, let's go through how to find the value numerically. So since we're told that we have parallel lines, make sure to mark your diagram. Angle EFG is 32 degrees. Make sure to mark your angles in your diagram. Angle AEG is 137 degrees. A lot of people put this angle in the wrong spot. They put it here. That is angle FEG. That's not angle AEG. Angle AEG is over here. So these two angles are supplementary. They form a linear pair. So 180 minus 137 gives me angle FEG, the one that is inside of the triangle. So that is 180 minus 137 is 43 degrees. Once again, this doesn't count because it's not in writing. I'm going to take a second, and before I forget what I just did, I'm going to put it into some writing. Make it smaller. Since angle AEG and angle FEG form a linear pair, angle FEG is 53 degrees because 180 minus 137 is 43. Now it counts. Now, inside our triangle, we have two angles, the 43-degree angle and the 32-degree angle. If I add up 43 and 32, I get, let me use my calculator, 75. And then if I subtract that 180, because all angles in the triangle sum 180, I get 105. Remember, it doesn't count unless it's in writing. Since all angles of a triangle sum to 180 degrees, angle FDE is 105 degrees because 43 plus 32 plus 105 equals 180 degrees. You can word it differently, but as long as you explain how you found that. You also could use these alternate interior angles over here. That's a little convoluted. This way is more direct. Okay. These are vertical angles, the two angles that we have information about. Notice the letter X formed by intersection line. And vertical angles are always congruent to each other. It's a really nice special property. So setting them equal to each other, we have x equals to 90, x equals to 30. Now we're looking for AEC. A lot of people plug in for the wrong angle. That's this one. All we have to do is plug right in. 4 times 30 is 120, minus 40 is 80 degrees. So make sure you box your answer, make it clear. Angle AEC. Okay. So here I have to find B that's going to make this a parallelogram. So first I just want to see what we're working with here. I'm going to use the straight edge and just connect the points that we do have together. So I know that to make the parallelogram, B's got to be somewhere over here. So we could use the fact that opposite sides of a parallelogram are parallel. That's actually the definition of a parallelogram. In order to create this parallel line, you already have this line and this line, these two sides. So these two sides over here, oops, get my pen, give me 1 second, my stylus. So these two sides are already perpendicular over here. So if we make another line that's also perpendicular to this line, it'll be parallel to this one. So let's do it. I'm going to grab my compass. Let me just get it. It goes to the top over here. It's so annoying on the computer. Most annoying thing ever. Okay. So what I'm going to do is I'm just going to slightly, also to make my construction easier, I'm going to slightly extend the side. I'm using a dotted line because it's not actually part of my construction. As you can see, that wasn't perfect. I'm using a computer, so mine's going to be pretty inaccurate. The computer's terrible. At least this program I'm using is pretty terrible for constructions. So what I want to do is I just want to make an arc or a circle. And it doesn't matter the distance. The only rule that you need to do here is that you need to make sure it intersects the line in two spots. And that's why I extended the line so I can see that intersection point on the left. So now I'm going to go over to one of those intersection points. And I'm going to do my best as accurately as possible, even though this is not very accurate on here. Open up the other one. I think that's as best as it can get. Not super precise, but whatever. And I'm going to make a circle. And then using that same distance, I'm going to go over to the other intersection point. And I'm going to make the same circle. Actually, came out better than I thought it would. It's not wonderful, but better than I thought it would using the computer. And now through the intersection points, I'm going to connect through the top and the bottom intersection. And it should come really close to passing through A. So now I just need to ensure that these sides are the same length as each other. And a lot of people are just trying to make all the sides congruent. It's not possible because the two sides that we were already given were not congruent to begin with. Parallelogram doesn't necessarily have four equal sides, unless it's a special kind of parallelogram, known as a square. We're going to see later on. So I'm just going to measure, and then I'm going to pick my compass up and measure. And that's my T. Nice. There's my parallelogram.